Welcome to ACI, the Network Made Simple learning series. In this video, we will cover
Module 6, Advanced Topics and Other Integrations, VMware NSXT, and ACI integration. If you remember, in Module 2, we learned how ACI integrates multiple types of virtual networks through APIC, including VMware VDS, Hyper-V, and Red Hat, amongst others. This approach allows both networking and VM admins to configure, monitor, and operate the same network while preserving their own tools and skill sets either through APIC or, in VMware's case, using ACI vCenter's plugin. It is no secret that VMware NSXT and Cisco ACI are competing solutions. However, your company may already have invested in both. Therefore, I wanted to put our differences aside for a minute and show you how ACI can improve operations for your NSXT environments if you decided to go down that path. With NSXT, VM admins may configure a network overlay and its policies through a separate management tool called NSXT Manager. NSXT Manager connects to vCenter through APIs, just like Cisco APIC. In order to provide an overlay, NSXT uses a physical network or underlay, which is a routed network commonly configured by the network admin, and which is not integrated to an NSXT virtual network in terms of configuration, policy, and visibility. In NSXT, the VM admin has to configure both vCenter and NSXT Manager, and in order for the overlay to work, they will also have to implement concepts like T0 and T1 virtual routers for communication and services. This means that understanding concepts like VRFs, BGP, NAT, and many others will be required, which may be overwhelming, especially if the VM or NSXT admin's core skill set is VM-centric and not networking-centric. Based on my experience, when companies adopt NSXT, it may be mainly because of its microsegmentation capabilities, which may be preferred to be defined by the VM admin in some organizations. However, nobody likes to have additional work, right? In this case, we're talking about networking, VM provisioning, and security, all for the price of one, because we're not going to get 3 different paychecks, right? Additionally, this usually creates additional silos and potentially slower provisioning and troubleshooting times. This is why ACI now supports NSXT integration as VMM in versions 5.1 and later. The main objective is to integrate both worlds when needed, normalizing networking operations and reducing overhead to the VM admin while preserving NSXT microsegmentation capabilities if desired. ACI to NSXT integration just takes 3 simple steps, and it follows the main concepts you already know. First, you have to create an NSX VMM domain, which is called VMware SDN in ACI. Then, you associate your compute nodes to the transport zone on NSXT Manager. And last, you associate your EPGs to the NSX domain you created on step 1. That's it. Let's now take a closer look at these steps and how the integration works. Just like ACI, NSX relies on VDS as a virtual switch, especially if you are using ESX7 and later. Therefore, the first thing we will need to do is to create our VDS, and we can do so using our traditional VDS VMM integration as covered in Module 2, Episode 4. Then, once we have our VDS integration running, we will add NSXT integration to APIC by creating a VMware SDN VMM domain. By doing this, APIC will establish a relationship with NSXT Manager and will also request to create a VLAN back transport zone or use an existing one. Transport zones are used by NSXT Manager to control which hosts and VMs can participate in a particular network. Those transport zones can either be overlay-based or VLAN-based. ACI integration to NSXT is based on VLAN-based transport zones, which allows to consolidate both underlay and overlay functions on ACI, removing the need for complex network configurations through T0 and T1 virtual routers, and leveraging network hardware performance while preserving microsegmentation functions on NSXT Manager, as we will see. Then, we'll go to NSXT Manager and add the compute nodes to the transport zone created in step 2. And last, we will need to associate our EPGs to the NSX VMM domain, which will request NSXT to create an NSX DV port group on the vCenter VDS with the right VLAN from the VLAN pool. Let's now perform these steps on APIC. First, I'll go to my VM networking section to show that I have an existing regular VDS VMM domain configuration called WWNSX, and another one called WWVDS. The former is the VDS NSXT manager will use once I configure it, while the latter is the one I am currently using for my VMs to communicate without NSX. If we take a look into vCenter to confirm this, we can see that both VDSs already exist in vCenter, and that the two ESX hosts that I have are associated to both VDSs through different uplinks. As mentioned, I currently have two VMs associated to the VDS with no NSX integration, which currently belong to the same EPG called Web, running in the tenant prod and application profile SAP. If we open a console session to both VMs, you can see that communication is successful between them. Both of them are running in the same EPG on vCenter, and the WWVDS domain is currently associated, as you can see. So let's go ahead and create an NSXT domain now. We will do that in the Virtual Networking VMware SDN section. Before we add it, let's first log into NSXT Manager to look at the existing transfer zones. As you can see, we currently have two default transfer zones plus a third one I created. So I'll go back to APIC and I will click on Create Domain. I will add a name to it, and I will select a VLAN pool so that ACI can dynamically associate VLANs to each EPG we create. In this case, it will include VLANs 2150 to 2160. The same physical network configuration basics still apply. Therefore, we will associate this VMM domain to the AAP that connects to the ESX servers. And last, I will add my NSXT manager credentials. That's it. Now, as you can see, we are not seeing any hypervisors nor virtual machines in the inventory for now. And that's fine, since we still need to add the hosts to the transfer zone. So let's go back to NSXT Manager and hit the refresh button. As you can see, we now have the VLAN back transfer zone from APIC, with no transferred nodes associated. So let's add the ESX servers that we want by going to the Node section and selecting them. I will select the .73 host first, I will leave the defaults, which have VDS as the switch type, and I will select the VDS called WWNSX. I will then assign this node to the newly created transfer zone, and I'll click Finish. It seems we're now done. If you have other nodes that you want to add to the transfer zone, you simply have to repeat the process. I'll just do this one for now, and then I'll go back to APIC and hit refresh. As you can see, we now have the transport node showing up in the inventory, along with its VMs, status, and more, which allows us to see connectivity alarms directly from NSX. Let's now go back to our logical network configuration, and in our application profile, let's click on the Web EPG, where currently both VMs are attached to, using the regular VDS and its VLAN pool. If we go back to vCenter, you can see that as of now, there are no EPGs or port groups in the WWNSX VDS, and communication between both VMs is still working through the regular VDS. I will now add my NSX VMM domain to the EPG and hit Submit. If we now go into vCenter, you can see that the Web EPG now appears as an NSX port group using one of the VLANs from the VLAN pool we defined. If I now change the settings for one of the VMs to use the NSX port group instead, we can see that communication is still successful. And if we verify the EPG endpoint assignments, we can confirm that one VM is using the regular VDS to communicate, while the other one is using the NSX integrated one, preserving the same level of visibility for both underlay and overlay on the ACI fabric, and without creating T0 or T1 routers on NSXT Manager. Now, if we wanted to create a microsegmentation policy on NSXT Manager, we can still do that. I currently have a policy called myPolicy, which is set to match all traffic from my F5 web server 1 VM to any destination. As you may remember, we currently have communication between both VMs using different virtual switches through ACI and NSX living in the same EPG. Let's now change the microsegmentation policy on NSXT Manager to deny all traffic from my F5 web server 1 VM and save the changes. As you can see, traffic is now blocked due to the policy defined on NSX, allowing a flexible model for VM admins to define and create microsegmentation policies when needed without learning and potentially troubleshooting complex networking concepts through separate network consoles. We can always go back to NSXT Manager and revert back to allow all traffic just like it was before. As a summary, if your company chose to run NSXT in your environment, we still want to improve your network through ACI by consolidating and normalizing how you provision and manage the network on any hypervisor, container, and cloud platform, maximizing the skill sets each admin may have in your organization and reducing operational silos that may slow down innovation and time to resolution.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.